perfect squares is going to look like something like this, where you have one square and another square, and the difference means you're subtracting them. Okay, so that would be like 9 minus x squared. That's a perfect square, and x squared is a perfect square. Okay, or I could say 49 minus x squared. And the order could be different too. I might have something like x squared minus 36. Those would be a difference of squares. All right, and I could have another square in front of this square. I could have 25x squared. That's a square, and that's a perfect square. All right, so basically, if I'm taking this factor, a plus b times a minus b, all right, remember if I were to FOIL that, that would be a times a is a squared, and a times negative b is negative ab, and then b times a is a positive ab, and then b times b would be negative b squared. And so these middle terms, they add up to 0, right? So they go away, and you end up with a squared minus b squared. All right, so what that means, all right, if I'm factoring this difference, if I'm looking for what I can multiply together to get the difference of perfect squares, it would be a times a, b times b, and one is positive and one is negative. All right, so following that pattern, I'm going to factor. So I'm looking for two factors, and I have a difference because these are subtracted and they're perfect squares. So if I take the square root of 121, I get 11 times 11. And if I take the square root of x squared, I get x and x. All right, and then I want the signs to be a positive and a negative, so that if I was to FOIL this, I would end up back here where I started. All right. So they're kind of nice. All right, because they have that pattern, so it can use a shortcut. So I've noticed that this is a perfect square and this is a perfect square, and they're subtracted. So I know I can factor these really easy. I just take the square root of this one, and I get 3x. And I take the square root of that guy, and I get, I think 14. I should check that out. Okay, so it actually is 16. So I'll put that over here. 16 times 16 is 256. So, and then I want a plus and a minus so that I get a 0 for my middle term. And so you can see that's really nice. If you recognize this pattern, you could box these. But when the numbers get really big, it's just way easier just to look at follow the pattern. So let's keep going. We've got 49, perfect square. X to the 4th is a perfect square. All right, so here I go. And the square root of 49 is 7. So 7 times 7 is 49. And x to the 4th is x squared times x squared. Would be x to the 4th. And then I've got a plus and a minus, and that's it. All right, and then so now I'll do this next one. All right, again, I've got a perfect square and a perfect square, and they're subtracted. So I've got 9 gives me the 81, and x gives me the x squared. To get the minus, I'm going to have a plus and a minus. And then I've got 100, so that would be 10 times 10. And then to get the y to the 4th, that would be y squared and y squared. And that's it. Okay, so now I'll go to the next one, and I've got 64. So the square root of that is 8, so 8 times 8 is 64. 10, or 100 is 10 times 10. W squared would be W times W, and then you've got to have opposite signs, all right? So you get a, all right, now those are perfect squares. You could also have perfect cubes. All right, cubes would be a to the third power and b to the third power. And then, but this time you can have a sum where you're adding them, or you could have a difference where they are subtracted. And both of those you can factor. All right. The kind of trick here, the thing to help us remember how to factor these is SOAP. And that has to do with the signs. All right. We're going to end up with a binomial and a trinomial. All right. And then the signs are going to be the same. This one is going to be the same right here. This is going to be the opposite right here, and this is going to be always positive. Right? So, and that will make sense in a moment. All right, so now we want to think about the first 10 perfect cubes. So if I have 1 cube, that would be 1. If I have 2 cubed, that would be 2 times 2 times 2, so that would be 8. 3 cubed is going to be 3 times 3 times 3, so that's 27. 4 cubed is going to be 4 times 4 times 4, so that's 64. All right, if I do 5 cubed, that would be 5 times 5 times 5, so that's 125. All right, and when I get up here, I can use my calculator. I can go 6 cubed, right, the up arrow, cubed, that gives me 216. Okay, and if I do 7 cubed, so I'll do 7 to the third power. Cube means to the third power. So 7 cubed is, oops, what was that? 343. Alright, and then if we do 8 cubed, 8 to the third power is 512. 8 to the third power is 512. 9 to the third power is 729. And then 10 to the third power we can do, because that, we know, exponential notation, we just have 3 zeros, right? Okay, so those are perfect cubes. So what that means also is if I took the cubed root of 125, that would be 5. All right, and to do that on your calculator, if you do math 4, that's the cubed root, and then I'll put in 125 and hit enter, and that gives me a 5. All right, so if I take the cubed root of 216, that would be a 6. All right, so on your calculator, you do math 4, you get that little cubed root, and then you do 216, and that gives you a 6. Okay, so factoring these, we've got this pattern here. And notice if I'm going to multiply these polynomials, remember we would go a plus b, I'm going to do the box method. All right, times a squared minus ab plus b squared. All right, and go ahead and multiply these together. So a times a squared is a cubed, and then a times a is a squared, and then that would be b, and that would be a minus, and this would be ab squared. All right, and then if I do b times a squared, that would be a squared b, and then if I do, this would be a minus, and I've got an ab squared, and then now I've got b to the third power here. Well, notice that A squared B, I've got a positive and a negative, so those add up to 0. And I've got this, a positive and a negative, so that adds up to 0. So what's left is A cubed plus B cubed, all right? And so same thing here. If I was to multiply these by, or excuse me, multiply these together, I've got A minus B times A squared, AB, B squared. And if I'm multiplying them, A times A squared is A cubed. And I've got an A squared B and an AB squared. I'm just distributing this A to all of these three. And now I'm going to distribute this negative B, so that would be A squared B, but it's negative. And this would be AB squared, and it's negative, because of this negative. And then this would be a negative B cubed. All right, and then just like before, this term and this term are the same except for the sign, so they add up to 0. This term and this term are the same, so they add up to 0. So I get A cubed minus B cubed. All right, and then notice this is where that came from. So these are equivalent. All right. So, and this is where we get our same. That's where we get our SOAP. Notice if this is plus here, this was also plus, and then this is the opposite sign, and then this is always positive. All right, so that's where we get that pattern. And then here we have the difference of cubes, and so they'll get the same sign here, the opposite, and then always positive here. Okay, so following this pattern, we can factor. So I know that I'm going to get a binomial and a trinomial, and because I have perfect cubes, right, because the threes. I have these little threes, so these are perfect cubes. And so that is going to be SOAP, so it's going to be same, right? Whatever this sign is, it's going to be same, opposite, always positive. All right, and then I just fill in the blanks. So I'm going to get, and I do the cubed root of this guy, which is A, and the cubed root of that guy, which is B. All right, and then over here, I'm going to have, I'm going to square this first term, so that will be A squared. I'm going to multiply the two terms together, so that would be AB, and then I'm going to square the last term there, so I get B squared. All right, and then this would follow the same pattern. You get a binomial times a trinomial. This is a negative, so it's same, opposite, always positive. And then you cubed root this, so that would be A, cubed root that, so that's B. And then you're going to square the first term, multiply the middle, multiply the terms together, and then square the third term. Okay, and that's, some formulas are sometimes confusing. So let's look at some numbers, some examples. So I've got a perfect cube and a perfect cube. So I know that that is going to equal a binomial times a trinomial. And I'm going to think SOAP. Right, so same, opposite, always positive. And then now I'm going to do the cubed root of each of these terms. So I'll do the cubed root of 125, which is 5. So that goes first. Since this term is first, this 5 goes first. The next term is cubed. The cubed root of x, so I'm going to put an x here. All right, and that I keep that order the same. That was second, so this is going to be second. All right, and then now I'm going to square, multiply, square. So I'm going to take 5 squared is 5 times 5 is 25. I'm going to multiply these together, and then I'm going to square this term, so I get x squared. All right, so now I have a perfect cube, so now I'm going to have a binomial times a trinomial. They're added, so I'm going to do SOAP. That would be same, opposite, always positive. And then I'm going to cube root this, so I get 2y, cube root this, so I get 6. And then I'm going to do square, multiply, square. So that would be 4y squared. Multiply these together, so that's 12y, and then square that term, so that would be